from the heart of Dubai, where tomorrow is being built today, to the world. Welcome to the CTO Show with Mehmet. Here, we redefine technology and reimagine possibilities. With Mehmet, delve into the riveting realms of AI, cybersecurity, and digital technology. Experience the thrilling highs and lows of startups. Immerse yourself in the spirit of entrepreneurship and witness the future of business innovation being written in real time. Now, without further ado, let's tune in and explore the future.
Hello and welcome back to a new episode of the CTO Show with Mehmet. Today, I'm very pleased to have with me Karwing, the CTO of LiquidStack. Karwing, the way I like to do it is I keep it to my guests to introduce themselves and let us to know more about themselves about what you do.
Sounds good. Hi, Mehmet. Thanks a lot for having me on your show. I'm CTO of LiquidStack. I originally grew up in Germany, actually, and I founded an IT consulting company back then to optimize business processes. We were serving major German companies like, for example, Lufthansa, Motorola Germany, and so on. And after that, I was taking up regional and global senior management roles at one of the top utilities companies. And then in 2012, I've co-founded a small company, originally to do Bitcoin mining, actually. And we were trying to find out how could cool down the Bitcoin mining chips in subtropical Hong Kong with hot and humid summers. So it's actually a small company. Originally, I've cut everything from mechanical engineering, 3D design, cooling, obviously, piping design with pressure drop simulation, leading down to cutting and crimping pipes myself, and integration of electrical systems and electronics. So I saw very good insight into almost all technical aspects of our business. It was very challenging back then, but we pulled it off, and we were worldwide the very first company which has deployed a large-scale two-phase immersion cooling technology for data center applications. And since 2012, we have 4 times consecutively deployed the world's largest immersion cooling data centers with up to 120 megawatts of IT load. And just as comparison, the Hong Kong Stock Exchange data center, for example, has an IT load of only 8 megawatts. So it's quite large, actually. And later, we rebranded as LiquidStack, and we continue to research and develop liquid cooling solutions into sustainable and energy-efficient high-performance cooling products. And our company has grown very substantially. We have employees in multiple countries since then. My role as CTO is to lead the organization with research and engineering teams in Asia and the USA. I provide strategic direction to our teams and consult and advise, of course, on technical matters where necessary. And obviously, I need to stay up to date with technology to understand where the market's moving to and what is in demand.
Mm-hmm. That's great, Karwing. I really, like the story and what was going behind. So, if you can just tell me, when exactly was the moment you realized that traditional data center cooling, it's not working anymore. Something need to be changed.
Right. So maybe a little background between air cooling and liquid cooling that provides a little bit more understanding on the matter. So air cooling obviously requires air as a medium to transport heat away, but it's very ineffective in transporting heat away versus liquid cooling. And since it's so ineffective, it actually requires much more surface area than a normal chip could provide. And so typically you find very big and bulky heat sinks mounted on top of CPUs and AI assembly chips, right? And some of those heat sinks, they can be now as tall as 4 inches or 100 millimeters. It's very astonishing seeing some of those AI servers with up to 8 of these heatsink towers mounted on top that are weighing so much and require so much space. Whereas the actual PCB with the chips is only a fraction of that volume. And back then, when we were setting up our Bitcoin mine, we were really benchmarking various cooling technologies against each other. So, for example, we've been looking at the latest and greatest of air cooling. We have been looking at, for example, DTC, direct-to-chip water cooling as well, with cold plates, as well as single-phase immersion cooling and two-phase immersion cooling. And after benchmarking those different technologies with each other, we saw that the two-phase immersion cooling was really the most suitable one for our technology back then. And then the great advantage of liquid cooling versus air cooling is really the much higher thermal conductivity. What specifically is two-phase immersion cooling. And, so we use dielectric fluids, which means that they're not conducting any electricity. And unlike, for example, the air cooling, where you have like one or few heat sinks mounted on top of the chips, our electronics are completely immersed in that liquid that provides cooling all around and not just about focus on those areas where the heatsink has been mounted on top. So with two-phase, we use specifically fluids with a very low boiling point, for example, 50 degrees Celsius. That's about half of the boiling temperature of water. The heat transfer with boiling phase change from liquid to gas is so effective in transporting the heat away that it could even replace some of the big bulky heat sinks with very thin copper boiling plates, just a few millimeters thin. So we have built systems which were able to save as much as 90% in space versus air cooling using heat sinks. So just think about how much space you could save if you extrapolate it to a data center. And that really gave us some understanding in terms of like, this is very interesting, not potentially only for our own application, but also for the data center application.
Mm-hmm. And Carwing, like, from, because when I was researching, so how this technology specifically address the problems associated with high power semiconductors?
Right. Yeah, that's a great question. Nowadays, these high power semiconductors, like CPUs or AI center chips, they can consume something like 700 watts of power. I'm not sure, maybe you still remember way back then, there were like CPUs at maybe 10 watts, 15 watts, 20 watts, right? So it's no comparison to what's demanded as of today. So this poses immense challenges for cooling. The big bucket heat sinks are needed to cool down. And in terms of these high-powered electronics, if you put a lot of them together in a server rack, for example, then you multiply basically the cooling challenges. So APC, for example, they have performed a study to show that a server rack with 20 kilowatt of power load would need something like 2,000 cubic feet of air per minute. So if you could funnel this kind of air volume, airflow, right, through 1 foot wide duct, like 30 centimeters, would generate wind speeds of about 56 kilometers per hour for one single server rack, right? And then those latest AI chips, they are, for example, design recommendations for AI clusters, where they even go up to 35 kilowatt per rack. So that's a factor of 1.75x on top of what I just mentioned. That's really just mind-boggling how inefficient air cooling becomes at such power densities. So that's really what we saw, that with liquid cooling, you can save a lot of energy. And that's really addressing these kind of problems coming towards us, especially with AI in general, and generative AI especially.
Yeah, actually, like you mentioned, the use of energy, but I think you touched base also on the space required as well, right? So it's not just the energy that will be consumed; it's also the space that is required for the traditional one. Now, a question out of mind, and maybe it's a little bit kind of unusual question, like. We see these cooling technologies at data centers, but have you thought to make it? Because I know, for example, a lot of my friends, they like gamings, and I see that they have these very weird cooling system. Is this something that it can be also be deployed like for home users also as well?
Yeah, absolutely. I mean, we have, for example, some small systems which we have displayed as well as exhibitions. And indeed, we have been putting, for example, some normal gaming mainboards in there with up to 4 GPUs. I think even more, 5 or 6 GPUs. And they were running basically some simulation. So it is possible as well to use it at home. But our technology is really targeted more towards the data center application, where you really have really very, very difficult situations to pull down to electronics.
Mm-hmm. Now, you mentioned that you rely on this technology, but you don't use water. Why this is important?
Well, nowadays, data centers, for example, they have been continuously trying to save energy, right? So in the beginning, they were using only, for example, air cooling, and then something like air conditioning, be very simplified. So they're using, like, for example, computer room air conditioners or computer room air handling units, and those to operate those energy efficiently. Most of them, for example, they use evaporative cooling, meaning like they have something like water tower, or they have like water spray to make use of the evaporative cooling effect. So what it means is basically like if you sweat, and the sweat is evaporating from your skin, providing cooling, right? And the problem with that is that with the increased demand of cooling for so many more data centers, the water consumption has increased dramatically. That's been, for example, some time ago, I think the US NSA, the National Security Agency, they wanted to set up a data center, I think in Utah, and the citizens from Utah, they were actually protesting against the setup of such a data center because they were concerned about the massive amount of water consumption such a data center would have. So this really highlights that nowadays there are many aspects in terms of from a sustainable operation for the data center, which doesn't only go around in terms of producing the electricity consumption, but as well as, for example, as well for cooling the water consumption. So we see a very strong push towards regulations, for example, towards greener data centers.
Yeah. Now, you mentioned AI a couple of times, and of course, we know it's AI, and it's like the high compute environments. So, for the audience that maybe they are not that technical, but can you elaborate a little bit on the challenges that AI poses on traditional data center infrastructure, and of course, why we would need or require your technology for cooling?
Sure. We've touched upon this a little bit in terms of some of the high-power chips, and especially those AI chips. They can have 700 watts, some even more than that for one single chip. But that's just about like the power consumption per chip. If you take a look at the outer packaging size, but if you look deeper into the chip itself, then, for example, you will see that the actual silicon die is even much smaller. So you have a very, very high heat flux with that large chip packaging, meaning that, for example, for 700 watt chip on, for example, 8 square centimeters of a silicon die, they have a very, very high concentrated power and heat. So these chips, for example, they can already achieve 100 watts per square centimeters. And that's actually about the same heat flux as inside a nuclear reactor. And just as a fun fact, most nuclear reactors actually use two-phase immersion cooling as the most effective cooling methodology. And obviously, it has to be reliable too, right? So, and these are figures for today's AI chips, right? Like what's available as of today. But if you look, for example, at the chip roadmaps, what's coming up in the future, they have even higher heat fluxes. So the problem of heat generated by AI applications and similar high-performance computing applications, those issues are not going to go away. They're actually becoming worse. So it's really something where we see that there's no other choice to sustain the operation of AI and HPC application than looking into using liquid cooling.
Got it. Now, how you are seeing, Karin, where we are going with this? I mean, in other sense, how data centers in general must evolve to keep, supporting this growing demand of low latency compute and edge AI. Like you touch base from cooling perspective, but also like because you have to deal with a lot of maybe some of your customers who have these large data centers. So what they should do different to keep the support for this high demand that is coming because of the AI and high performance computing?
I think in general, it's important for customers to keep in mind whether they are able to implement new technologies to operate their data centers more energy efficient. So, for example, some time ago, we have created a data center study with Page. That's a US-based data center and architecture consulting firm. And for them, they have created a study of a hypothetical 36 megawatt data center to compare two-phase immersion cooling with air cooling. And some of those key points were, for example, that if using two-phase immersion cooling, we could save around 32% on the data center space and about 61% of the white space. That's actually like where the server racks are located in. And this and other savings led to an overall saving of about $123 million, or about like a third of the entire cost. So if data center operators, if they are looking into high performance and AI applications, I think it would be worth it to keep an open mind in terms of what kind of cooling technologies and other technologies could be implemented to make their data centers more efficient.
Yeah. Now, question, Carway, like we started to see, I live in Dubai, and we started to see, everyone, because there's the COP28 coming, and, there's a lot of talks about sustainability. Actually, they have built one of the largest data center, which is powered by solar power, actually. So for such initiatives, how, LiquidStack can, add value for countries, companies who want to have this sustainability as part of their long-term strategy, and of course decreasing carbon footprint and so on.
Yeah, very interesting point. Thanks for raising that. So obviously, locations like in the UAE, Dubai, right, but as well as Hong Kong, Singapore, all with some very challenging climates, it's not going to be easy to operate on data centers in the future. So you see, for example, very long PUE figures, meaning like power usage effectiveness figures, in countries where it's rather moderate in terms of climate, right? Not so hot. But if you move to countries where you have a very challenging climate, then cooling, of course, becomes a very big challenge. And nowadays, you mentioned, for example, as well, low latency applications. Nowadays, you are not necessarily able to always have a monolithic data center only in one single country. Several countries, for example, they have a certain data residency regulations. For example, that they prescribe that data about the citizens should not cross borders. Or, for example, there are medical data which you want to keep to certain hospital and things like that. So what we see in terms of trends that they are certainly more focused on localization, that there are data center and compute applications which are more localized, so that they can serve the local users much better. But then, as mentioned, you may run into cooling challenges and so on. And this combined with AI and HPC applications in general really poses a significant challenge. So, for example, most enterprises and companies, they don't operate data centers as their core business. Not too long time ago, supercomputers were really something what government organizations and universities have said, right? But if you have read, for example, recent news of Tesla launching a $300 million AI supercomputer with 10,000 NVIDIA accelerator chips, it's quite obvious to see that more and more enterprise and companies are seeing the need to use AI and compute in general to stay competitive, right? So all this in combination really requires the demand for looking into a much more sustainable way to set up data centers. And then you mentioned, for example, data centers completely powered by solar electricity. And that's definitely a very great and correct way to approach this problem. But with solar cells, problem as well about energy storage. So on daytime, it's all good, of course, and you have sufficient power for your data center. But in nighttime, you need to find a very efficient storage solution for it. And even then, if you spec out, for example, the solar cells or whatever generated energy generation from data center, if it's possible to save on the cooling side, you basically free up more electricity, for example, to run instead more compute. You can put, for example, more AI chips in there. You can put in more CPUs in there instead of spending the electricity on cooling. Then there are some data center locations where they have, for example, power issues. Like, for example, Singapore, they have up to 7% of its entire electricity being used for data centers. That's really astonishing, right? And but for those, for example, they have already had something like a moratorium, meaning like no new data centers are supposed to be built anymore. And they've changed it in the meantime to have like a power cap. So basically, like that data centers can only use a maximum number of megawatts, and but there are already voices coming out in terms of like what does it mean for the future growth of the data center industry in Singapore? And Singapore isn't the only example. There are other examples like Amsterdam and other places as well, and cities where they have similar restrictions. So efficiency is really becoming more and more important. And how can you maximize what's available to still allow sufficient growth capacity to stay competitive?
You know, this is really an interesting point. And as you mentioned, data residency is one of the biggest challenge. It's not a challenge, like it's by regulations, data cannot leave some countries, especially if it's like very maybe personal identification data or medical records. You're completely right. And this is, we saw the hyperscalers, trying to start to build the data centers. Like, do you have any collaboration with these hyperscalers, to provide your technology to them, Carwing, also? So because, like a couple of years back, I think, we start to see that I think Microsoft were planning to build data center under the sea, and we started to see, they were going to cold countries kind of to build the data centers. But as you mentioned, now I can tell you here in the Middle East, we have like in the GCC, 6 countries. So almost in each country now we have 2 data centers for each one of the big hyperscalers. So do you have any collaboration with these hyperscalers, Carwing?
Yeah, of course, like in many commercial aspects, usually we have confidentiality agreements with our customers. It also applies to the hyperscalers. What I can say is definitely we are having collaboration with hyperscalers, but I can't name exactly which ones.
Yeah, sure. That's fair enough. Fair enough. Do you have any, like where are you spread today, like Carwing? Of course, if you can tell me, do you have any presence, for example, here in the Middle East, so people can go and find out about your solution? Or is it like something which is, usually it's in the hidden part that, even tech professionals, they will not see it, I would say, face to face, if I can't say this.
Yeah, it's an excellent question. So yeah, we had some actually for our company size, quite good geographical coverage. As mentioned, we are having a good presence in Asia, in various countries, as well in the US. And just very recently, we actually made a hire in the Middle East, just specifically to support the Middle Eastern sector. And we will actually have, I think it is in October, after middle of October, there is the GITEX exhibition coming up. And we'll have some exhibition booth over there. And of course, you're more than welcome to visit our exhibition booth over there. And we will be presenting our technology with a live demo on two-phase machine learning. We can really see the system running, operating with all the bubbles while it's boiling. And I think it's very interesting to see. And it's a very interesting market for us, on which we want to focus.
Yeah, definitely. So just for the folks, if you are in the States or in Europe, so GITEX is the biggest tech event that happened here in the Middle East. It's gonna happen this year between 16th and 20th of October. My audience here in the region, they know about it, and it would be for you a chance, to visit. I think you're gonna have a booth, Carving, you said, so you can visit them and learn more about the technology. Now, just couple of final points before we close. How, just from a CTO perspective, because you Carwin, you are on, as I was mentioning, like it's not, on something that people sense every day. So from a CTO perspective, working on something high impact, but yet like less people knows about it. How does it feel like? And, and I'm asking you this question because some people sometimes they say, yeah, we want to change the world, we want to do something, but we want to be also like touching the lives of people on day-to-day basis. But for you, actually, you are saving the people, but you are not too much on the on the front end, I would say. So from a CTO perspective, like how do you describe this experience?
It's very interesting. Well, I'm not how to say too keen in terms of like but that I have a very big focus for that. I believe really like in that doing and really taking action is much more important. If something comes good out of that, of course, and it's very much appreciated. So they're very richly, right? And we were sitting at the company to do Bitcoin mining. Back then, it was really about how can we run it as profitable as possible. And then it very quickly emerged that, especially in hot and humid Hong Kong, it wouldn't be only possible if at the same time it would also be reducing our electricity consumption, especially on cooling. So very soon after we wanted to explore if our technology also could be used for the data center industry, we have done some research on the data center industry in Hong Kong at least. And we have seen that, for example, there have been like power usage effectiveness, PUE figures in Hong Kong for data centers in 2012 at 2.2. So just for the non-data center industry audience to explain, PUE of 2.2 means that out of the entire data center electricity market, you use only 45% to run your IT. So just imagine you build a huge data center, right? And we want to run servers, but actually you only use 45% of your electricity to run the servers. More than 50%, more than half is actually going into your facility, that can power the cooling and lights and stuff like that. And that's really like very shocking when we saw on how much energy is actually being wasted. Of course, there's improved in the meantime with better technology and cooling in general, but we still see a very, very challenging problem with that. And then we've seen as well that in Hong Kong has sometimes better air quality. And it's actually, unfortunately, no big surprise if considering that about 2/3 of the electricity still being generated by burning fossil fuels. This, unfortunately, as well applies to many countries worldwide, not only Hong Kong. So, and on top of that, Hong Kong landfills already almost at capacity. So if we have a possibility, for example, to save on construction materials by making the data center smaller, and as well to save on cooling electricity by making the cooling technology more efficient, that's something becoming very strong motivators, not only to me, but to our team, but to have a much stronger focus on sustainability in general. And especially now with having a young family as well, with child, changes your perspective and priorities a lot, right? So at the end, we want to leave the world in a better shape for our next generation, not worse.
Yeah, just for also if you allow me, Karin, if to add something, for the folks, if you are non-tech at all, and I doubt that you're not, but like every single application used today, it's powered by some server running somewhere, whether maybe in a telco provider or maybe in a cloud somewhere. And, it's not only about the cost of the server and the cost of the application, as Karin was mentioning. There's a huge things which are hidden in the background, like electricity. I was a data center technician at some stage, and I know these things very well. So you have the cooling, and the cooling there, guys, it's not like the AC that you have at home. So the cooling system there, you need to have like proper fans also for it, so to keep the air flowing. And you have from underground something and you have something that comes from up. Because as Karin was trying to explain, the chips are very sensitive to heat, and especially when it's AI, they generate a lot of heat. So this is why, this technology is very important. Don't just say, yeah, it's just cooling. It's like the AC. It's not like this. It's something more complicated. And, we are thankful actually, Carwing, for people who put the effort, like yourself, and what you do with the LiquidStack to make the world a better place where we can have, less emissions, less carbon footprint, which is, really something, as you mentioned, especially when you have kids and children, you start to think about how we can leave this. I really appreciated, all the valuable information. Is there anything, Carwing, that you wished I had asked you? Did I miss anything you want to just add or say before we close?
I think you pretty much touched on every single point which was important. So it's just to add on what you just mentioned in terms of the every single action. There are some studies, for example, on sending emails, uploading a video, or something like that. All these kind of actions, they actually have data centers in the background running, operating to transcode, for example, a video into a format so that you can download it in all different types of resolutions. And all this, of course, is, I would say, almost inevitable in the meantime, right? And it's not about, but how can we go back to the Stone Ages? We need to live with this technology. We need to basically try to make the best out of it. And although people, for example, look at generative AI as something like, okay, I can use some ChatGPT maybe to do my homework, right? It's not as trivial as that. There are corporations out there, for example, they use Gen AI to, for example, find cures for cancer and other illnesses. Where, for example, they can do simulations and trying to find like a lock to a key, a very special protein which exactly matches certain properties to cure illnesses. And these kind of applications are very, very exciting. These applications require a lot of processing power. So this will not go away. We should really leverage on the new technology. But how can we use this technology sustainably? That's where we hope to contribute a little bit in terms of using, for example, coding.
100%. And thank you for adding this, Carwing. Yeah, exactly. ChatGPT, guys, maybe you see it as a game and you play to generate some text, but it's something more complex than this. And each actually time you press the enter button, there's a lot of compute power, which needs cooling as well. That happens. Carwing, thank you very much for being on the show. I'll make sure that I'll put the company website in the description notes. And for the audience, as usual, this is how we end each episode. Thank you for the feedbacks. I'm pretty happy to hear, that you are enjoying all the episodes. Keep them coming. If you are interested to be also on the show, don't hesitate to reach out to me. We can arrange for that. And as usual, thank you very much for tuning in today, and we will meet again very soon. Thank you. Bye-bye.
Excellent.
Hit that subscribe button. Share the show with your tech-savvy friends and fellow entrepreneurs, and leave us a review on your favorite podcast app. Your support means the world to us.